Hello and welcome to section 6.5. So here we're going to look at some property of logarithms that will help us solve more exponentials and logarithmic equations. So let's start looking at them. There's some basic properties here. It says that log of any base of the number 1 equals 0. So this comes from, if you change this to exponential form, you would get a to the 0 equals 1. Okay, so this comes from the exponential property that any base raised to the 0 is going to equal to 1. Alright, so a lot of the log equations are easier to understand if you switch them to exponential form. It's basically the exponent rules rewritten with logs. Alright, let's look at this. Log base a of a, so if this bases match, then we get equal to 1. Okay, so again, if we change this to exponential form, we get a to the 1 equals a, and that makes sense, right? All right, cool. Okay, so let's look at these are cancellation properties. So exponential and log cancel each other out if they have the same base. So a of log base a of m equals m. So basically, like these cancel. And in the other way, log base a of a to the r, because if the bases match, they cancel. Again, if you change things to exponential form, you'll see that, or to logarithmic form, you can see how that works out, right? Here's some new ones. Again, these are sort of reversing exponent rules. If you take log of any base of a product of two things, then you can split them up as a sum. Log of any base of a quotient, then you split it up as a difference. And if you take log of any base to something to a power, then the power comes down to the front and multiplies the log. Alright, and this last one is conversion of bases with e. You have a to the r, this is the same as e to the r log a. So this one you can see, like with this property here, if I move this r up here, we get a to the r equals e to the log of a to the r, and e and log cancel out because they have the same base, so you get a to the r equals a to the r. So they kind of combine each other, and they come from the original exponent rules that we looked at a couple of sections ago. Alright, so we're going to use those properties to evaluate each expression. Right? So part A, we have natural log of e to the square root of 2. Because the natural log has a base of e, and these match, then they cancel each other out, and you just get square root of 2. Alright, part B, we have log base 6 of 9 plus log base 6 of 4. Sum. We have sum of logs. We can compress it to write as the log of the product. So sum turns into a product. So this is log base 6 of 36. And now we're going to use another property. We're going to match bases. 36 is 6 to the 2. So if the base of the log and base of the exponential match, they cancel out, and we get 2. Part C, it's a subtraction. We have the same bases, so we can compress it into one with division. So log base 8 of 16 over 2. We simplify, log base 8 of 8 to the 1. These cancel out, and we get 1. And this one, e to the log base e squared to the 9. Right, that one's interesting. Let's see if we can change the format of this. Okay, so this is log base e squared of 9 equals log base e of x. All right. I think I can use, oh yeah, we can use this one here. Okay, because that says e to the r log a is equal a to the r. No, we don't think we can use that. Oh, all right, I think, okay, let's see. Let's see what we can get. All right, I like this one, it's interesting. So let's write this. We have e log of base e squared, and let's write 9 as 3 squared. Okay, then we can take the 2 in front. This is this property right here. The log of a power equals the product of the power of the log. So this is going to give us e to the 2 log base e squared of 3. Okay, so I'm gonna write this as e to the 2 to the log e squared and 3, and we can see that the bases match. So the base of this exponential is e to the 2, and the base of this log is e to the 2. Right? So this will be this property here, right? If you take an exponential of a log with the same base, then the answer is they cancel each other out, basically. So this is the same situation we have here. And the base of the exponential is e to the 2, the base of the log is e to the 2, so they cancel out, and the answer is 3. All right, that was a tricky one. All right, let's look at these problems. So again, we're going to use properties of logs. Suppose natural log of 2 is a and natural log of 3 is b. We want to use the property of logs to write each expression in terms of a and b. So don't put in a calculator. We want to do this by hand. Okay. So log of 2/3. This is a quotient. So this splits up as log of 2 minus log of 3. Log of 2 is a and log of 3 is b. So this changes into a minus b. Our next one, a log of 0.5. This is log of 1/2. So this is going to be log of 1 minus log of 2. I know log of 1 is 0 and log of 2 is a. So this simplifies to negative a. All right, we have log of 27. So we're going to change this into log of 3 cubed. Then take the power in front. 3 log of 3. Log of 3 equals b, so this is 3b. Right, part D, we have log of 4th power, it's 2/3 to the 1/4. Take that exponent in front, 1/4 log of 2/3. Then we're going to do the subtraction rule here, so this is 1/4 log of 2 minus log of 3. And 1/4 of a minus b. All right, cool. All right, so write each expression as a sum or difference of logs. So we're going to use the properties for sum and difference. This is a quotient. This means this is log base 3 of x minus log base 3 of 9. We're going to rewrite the 9 as 3 squared. So these cancel out, and we get log base 3 of x minus 2. Right, part B, this is a product. So we have natural log of x plus natural log of e to the x. These bases match, so this is natural log of x plus x. Right. Part C, we have log base 2 of a minus log base 2 of b squared. Take this exponent in front, so log base 2 of a minus 2 log base 2 of b. Let's look at this one. So we have a quotient, so let's split up log base 5 of cube root of x squared plus 1 minus log base 5 of x squared minus 1. Let's rewrite. So So this is x squared plus 1 to the 1/3. Log base 5. This one factors as x plus 1 and x minus 1. Right, for this, the 1/3 comes in front. So 1/3 log base 5 of x squared plus 1. This one I can split up into a sum. So negative log base 5 of x plus 1 plus log base 5 of x minus 1. Alright, so it's 1/3 log base 5 of x squared plus 1 minus log base 5 of x plus 1 minus log base 5 of x minus 1. Alright, and that's as far as we can go because these things in parentheses don't factor, so you can't split them up anymore. Alright, now we're going to go backwards. That's not the right instructions. We want to write the log as a single logarithm, so using those properties in reverse. So first you want to look at the coefficients. If you have any coefficients, you want to make them as powers. So log base 3 of u squared minus log base 3 of v. Then there's a subtraction, so this turns into division. So this is log base 3 of u squared over v. So you want to end up with 1 log of something, of an expression. All right, let's look at b. We see that we're adding here. So we have log base 2 of a product, 1 over x times 1 over x squared, which is log base 2 of 1 over x cubed. Okay? All right, let's look here. So this one, look for any coefficients. So that 2 I'm going to put on top. So we have log x squared plus 3x plus 2 minus log of x plus 1 squared. Now this subtraction is going to turn into division. So we have log. This factors as x plus 1 and x plus 2 divided by x plus 1 squared. So we can cancel one of these and we get log base 2 of x plus 1, 2 over x plus 1. Alright, D, look for coefficients and put them on the top. Log base 5 of 3x plus 1 cubed minus log base 5 of 2x minus 1 squared minus log base 5 of x. So we have log base 5 of 3x plus 1 cubed minus log base 5 of 2x minus 1 squared plus log base 5 of x. The sum we're going to turn into a product. So log base 5 3x plus 1 cubed minus log base 5 of x times 2x minus 1 squared. And the subtraction we're going to turn into division. So log base 5 of 3x plus 1 cubed over x, 2x minus 1 squared. There we go. Alright, so that's last thing in the section. Very important formula is the change of base formula. And this allows us to go from any base to any other base. So if I start with log base a of m, I can turn it into base b by writing log base b of m, but then you divide by log base b of a. So it's kind of the log of the new base of the old base. Okay, so this is important because you can evaluate any logs in the calculator. Okay, so if you look at a calculator, it only has log base e and log base 10 in there. So we can change this base into either ln or ln(g). So this is going to be ln of 18 divided by ln of 5. And we can plug that in the calculator, and that will evaluate log base 5 of 18. Okay, so ln of 18 divided by ln of 5. 1.80. Right? I could have also gone log of 18, log of 5. That gives me the same thing. Log of 18 divided by log of 5. You can see that, right? Or you could have done any base. Okay, I could have said this is log of 13 of 18 over log of 13 of 5. So you can change it to any base, but these are useful because you can plug them in the calculator. All right, let's do B. So log base 1/2 of 15. I'm going to change them to natural base, log of 15 divided by log of 1/2. All right, so let's put it in. So ln of 15 divided by ln of 1/2. And we get negative 3.91. There we go. All right, that's it for this section. Short one.